Hello, students. Okay, here this is PIMA 142 class, and this is lesson number 1.4 and deals with dimensional analysis. So our learning target is objective is you're going to solve problems using rates, convert between common measurements, and the third one is solve application problems involving conversion of units. So I'm going to go directly to what is the difference between the rates and unit rate. So here the definition of rate is just comparing two quantities of different units. So basically you have a ratio. That means an example of, maybe you can see this, in 10 hours you can drive 512. There you go. You can see this. So which the left side that you see here is the rate, but if you try to convert to dividing 525 by 10, so that's 52.5 miles every hour. So the denominator has to be 1. So we'll go directly to the problems. And here it is. So in your packet, you can see the first one. So an example one, you your car can drive 300 miles on a tank of 15 gallons. Now you're supposed to express this as a rate. So there are two questions. One is the rate, one is the unit rate. Now since they give you 300 miles on a tank of 15 gallons, you can take a ratio. So something numerator and something denominator. So I'm going to take miles in the numerator and the number of gallons. So gallons in the denominator. So we can write 300 miles. So 300 miles, MI stands for miles, and this is 15 gallons. So when you write in this form, that's the called this is the rate. But let's write this as uh, 300 divided by 15, and you want to know what is this answer times this is miles per gallon. Okay, so this 315 divided by 15 will give you 20. You can check, and this will be 20 miles per 1 gallon. So, and that is called a unit. Now, this is the unit rate that we have to use, like in this example. So, what is dimensional analysis? A method to convert one kind of unit to another. Now, the same problem they're asking you, the first question is the same. This information is given. So, how far can it drive on a gallon of 40? Drive on a gallon of, sorry, on a tank with 40 gallons. So that means that you can do in two ways. Okay, so this example number two is the first information is the same. Okay, but then how far it can drive in 40 gallons basic means we have to take the ratio. You can always do proportion. Okay, let me write this again. So, so we can make a ratio in. So the question is how far. So we don't know how far. That's like we can consider like a x. So x miles. So we don't know, and divide by on a tank of 40 gallons. So that is 40 gallons equals, and this one is given us the rate as 300 divided by 15, right? So that I'm gonna write here 300 miles divided by 15 gallons. Okay. So this is how we solved the problem earlier, where it is as good as writing 40 gallons, like no more gallons, just the numbers. And these are the problem that we did. And you can see the denominator here is the number, x is in the numerator. So best is multiply by 40 this side and multiply by 40 this side. Okay. And this 40 and this 40 crosses are in their x equals, so multiply this two on your calculator. Of course, we already worked this was this piece. We did this is 20. This part is 20. And when you multiply 20 to 40, you get 800 miles and you're done. Now the question is, this lesson we are not going to use this. We are going to use the conversion factor. What that basically means is you're going to start with, let's see, the question is, this is what is given to you. So this is given means you are given a rate. That means every 15 gallons is 300 miles. Of course, this is very easy, common sense. You know, it is 20 miles per gallon. But my question is, what if the numbers were difficult? Okay, this time they're asking you 40 gallons. So all you start with is the question was to know what is 40 gallons, how many how many miles does it give? You're converting from gallons to miles. Okay, so what we do in this case is you start with the dimensional analysis is what it says. You start with this, so we'll write 40 gallons. Okay? And this 40 gallons now is same as multiplying by 1. Okay? But instead of 40 gallons, we use the the rate. This is the rate. See? So this is actually is like 1. So that becomes 300 here, 300 miles, divide by 15 gallons. Now now everything depends on also one is you could write 15 gallons up, okay, and divide by 300. That also is, it depends on what question is. Now, because the gallons is here, which is numerator divided by 1, there's nothing here, means 1. So what I'm doing is I'm trying to get gallons in the denominator. So I'm going to use this piece here. This piece is used here. So that way we can cross out the gallons and the gallons. So we can cross out this and this. What I left is 40 gallons. Okay, 40 times. So 40 times 300 divided by 50, and this whole thing into miles. So this is what is left over. So this is the miles. So your answer, of course, will give you that same answer, which will be 800 miles, which you already worked out earlier. So two different approach uh, to do this. Or you can also use another uh, approach is directly using unit. You know that every 15 gallons it is 300 miles. You can drive. So that means 300 when you do this 300, it is like 20 miles per 1 gallon. So that means if you ask 40, all you do is that unit rate you can multiply 40. Use your common sense and get the answer. But my question is, see if you see the next question. So same question, but this time they're asking instead, how many gallons are needed to drive 50 miles? Okay. Now, because it is 50 miles is a question from 50 miles, how many gallons are needed here? So X number of gallons. We don't know. So you have to change from 50 miles to X gallons. So you start with 50 miles. So begin with 50 miles and then multiply by 1, and that one you replace it by the rate. Uh, so here you multiply 1, and this time because miles is given, so I'll use the rate as, because they gave us the earlier problem 300 miles, 300 miles for 15 gallons. So this is the one that you use. So there is a little confusion when do you use this, or when do you use this one? So this is the rate that you have to be careful which one you are using here. So here I'm going to use 300 miles can be driven with the help of 15 gallons. So this time this will cross out, and what are you getting is 50 times 15 divided by 300, which will be this whole answer will be in gallons. And that answer will be, you can check with your calculator, you get 2.5 gallons. So 2.5 gallons are needed to do that. So I hope I'm making sense. It's just to depend on. So there would be another approach also to know this. You can start with whatever they gave us. So they gave us 300 miles, right? 300 miles for 15 gallons. You can start with this rate also. You begin with the whatever that is, and then times. The question is asked. Uh, I, I think we should go for another example. So start with the easy ones, and then we'll build up because I don't want to confuse with too much of stuff in the same example. Now, in example three, Paul is shopping for laundry detergent, and at the grocery store, the liquid detergent is priced at this 64 loads here. And then there is another one with powder detergent, which is priced at this one. See, so a lot of information is given. So what do you want to know from here is which one is the cheapest per load. So which one you're going to buy? Are you going to go for liquid detergent? So which detergent has the lowest per load? We need to figure out each time the blue color. So you can divide this into two parts. That's what you're doing for liquid and for powder. So for each case, you do the unit rate. So let's see if I want to find the unit rate, and what is the unit rate is so many dollars for 64 pounds. It means how much money you spent, that is 14.99 divided by 64. So this is in dollars, and the down one is the number of loads. And if you use the calculator, you get 0.23 dollars per load. Calculate L stand for load. But if you do the other one, this will be you're spending $15.99 with 80 loads. Okay, so when you use the calculator, you get 0.1999, which we can round it to $0.20, which is like 20 cents per one load. You can clearly see this is 0.20 is less than 0.23. It means uh, the powder detergent is more cheaper than the. Okay, so I hope that part taken care. And now we have to do the next one. So if you see the example number 3.2, so this is about going from LA. So let's see, you're driving your Civic Honda from Tucson to going to LA. Okay. So that means if this is Arizona, this is California. We are here. You want to drive all the way to LA, and that distance is given to you as 485. This is 485 point. Yeah, this is 485 miles from Phoenix. Sorry, Tucson. This is Tucson, and this point is LA. Now, the Civic Honda, they gave us the rate per gallon, 37 gallons. So 1 gallon, it gives 37 miles. The question is with the full tank from here, if you start, will he able to reach LA? So all you do is the distance is 485. Now, since the tank has 13.5, so we'll start with 13.5 gallons. So you start with 13.5 gallons, multiply, and this is the place you have to write the rate. The rate given here is this one. So we'll write 37 miles divided by 1 gallon. Okay. So this is how you use. So that means gallon and gallon crosses out, and you get 13.5 times 37. And this answer, when you put on the calculator, you get 499.5 miles. But the distance from Tucson to LA is 485. And you can say 485 is less to this one. Or we say less than means like this. See? So that means you are able to go with the full tank from here to here. But you can see these numbers are so close, 485 to almost 14 miles. But in reality, if you really want to drive, in this is in theoretically I'm saying. But in reality, if you really want to drive, of course, you in between will have to somewhere in between you'll always try to fill in the tank, right? So this is in theory, but practically you're going to somewhere you're going to fill in again the gallons so that you are safely reached in the alley. Now your packet has given us all this metric system, that is the length, this is this part, how to convert from foot to inches, yard to feet, all this given to you. This is about the volume, and this is about the time, and this is about the weight. So we'll see depending on what question they ask and how to do. So in this question, example number 4, so all of you know how to do this, right? But still I like to show my way. So I want to use the dimensional analysis. Okay, many of you will say, hey, how do you change from 12 centimeters to inches? I just wanted to show that your 1 foot is like this. Let's say this is like a 1 foot, start with 0. And I can break this as a 12 here. Okay, I'm just trying to show this is 6 inches, 7, 8, 9, 10, 11, and like that. Okay, 5, 4, 3, 2, 1, and then 0. So just want to show you this is like 1 foot ruler. Let's say this is like a 1 foot ruler, and every inch, let's say this 1 inch, at the bottom you will see it's given in the centimeters. So centimeters is metric system, like start from here to here is around 30 centimeters. So that means if you try to convert this, every inch, let's say this, every inch is given to you 1 inch. So you have to use the conversion factor that 1 inch is 2.54 centimeter. So another way to write the ratio is either you write 1 inch is 2.54 centimeter. This is one way to write. Another way to write the rate is you can write 2.54 centimeter up and write down 1 inch. So it all depends on what question is asked. And in this case, this is given to us. So 12 centimeters, and you need to convert this into inches. So this time, which one we need to multiply? Now they gave us this is in centimeters. So you look up for and this is like over 1, right? So you look up for the one that has centimeters down. And you can see this is the one that has centimeters down. So we're going to write a ratio, the rate, which saying 1 inch is 2.54 centimeter. So why do we do this? Is we can cross out. So we can cross out centimeter and centimeter, and we are left with. So what are you left with is 12 times 1 divided by 2.54. This answer is going to be in inches. So with the help of a calculator, I think you can check this. We're dividing by this, you get 4.72 inches. Of course, you can write this also 4.72, and you can put it like this. So that symbol also inches. The second question is asking you from 48. So let me wipe this off. is about 40. So you start with 48 ounce and you want to change it to pounds. This pound, so you want to know how many pounds. So this is in pounds. So that means you start with this. So 48 ounce now multiply by 1. Now that 1 is two ways we can write about the rate for ounce and 16. We know that, of course, 1 pound, this is writing regular writing. 1 pound is 16 ounce, right? That means we can also write 1 pound over the rate is 16 ounce. This is one way to write. Or you can write 16 ounce is 1 pound. So it all depends on what are you multiplying. Now, this one is giving you OZ, that ounce is given. That means it is divided by 1. So you have to do in such a way that instead of 1, you replace it by. So in place of 1, you replace it by. Your ounce should be in the down. This should be ounce. So you go for this one. So you have 16 ounce is 1 pound. So we can cross out this and this. And what I left is 48 times 1, this one, divided by this one and this 16. Use the calculator. The answer will be in pounds. So that you get, of course, common sense, you know the answer is already pounds. So many of you will say, hey, this is 60, 48. So you want to change to pounds, and 48 basically means 16 plus 16 plus 16, right? So which adds to 48. And each of the 16 ounce would be like a 1 pound. And this is another 1 pound. This is another 1 pound. So there are 3 pounds. So that's a shortcut, but not all the time it is possible to do. And that's why we show these steps called dimensional analysis. So the next one is 3 quarts. So I will begin with 3 quarts. Okay. So 3 quarts now multiply by 1. First I will change quarts to pints. Now remember, if you have this as a gallon, this is like full gallon. Okay, a gallon has got breaks into four quarts like this. You can put this into 4 quarts, and every quarts we can make it like a pint, two pints like this. So these are called the pints. So there are every quarts will be okay 2 pints. So this is 1 quart. So this is 1 quart. So 1 quart, I'll write shortcut as a QT. 1 quart is 2 pints. And pint shortcut is PT. Okay. So is PT. So and then again we'll try to now there's a pint here. So we'll 1 pint is how many cups? 1 pint. So every 1 pint you can see two cups. 1 quart I wrote already this, but this one, this each of this will be like a cup like this. So there will be 2 cups. So 1 pint will give you 2 cups. Okay. But every cup is each of this cup that I have drawn here. This is 1 cup is 8 ounce fluid ounce. Okay. So therefore we have to write 1 cup here is 8 ounce fluid ounce. Now we can cross out. So this quartz crosses out. This point and this point crosses out. And that means green color. This cup and this cup crosses. And everything that you get is eventually you are ending up with cups. See, our goal was to get this. So your number will be this 3 times this 2 times this 8 divided by 1, 1, 1. So anything it means 1, 1, and 1. So all this answer is in fluid ounces. And see when you multiply this, when you get 96, I think I missed one more 2 here. So that is 2. And you get 96 fluid ounce. And you're done. So that's all you can say, changing 3 quarters to how many ounces. Otherwise, also, you can, that another way to do shortcut is this gallon, every gallon is 128 ounces. So instead of writing all these steps here, we could also use shortcut. Instead of writing in between step, you can avoid and say, okay, let me convert directly from three chords that you have. So three chords, okay. We can write this. Let me use this Qt. So three chords. Let's multiply by, and we know one instead of in the form of gallon. So chords. Uh, so 128 is in one chord. We can break this into four parts. You can see it's like 32, 32, 32, 32. And you can see directly we can write. So 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 that is the four 32s, 32, 32, 32. That means one quart directly you should know it is 32 ounce. See? So we can skip in between the steps and then we can cross out this quarts and this quarts. What I left is 3 times 32 ounces. And this become 96 ounces. And you're done. So another way is to use your common sense and say, hey, there are 32, you're adding 32 plus 32, and you just add all this and you get 96 ounces. See? Because each quarts is 32, and that way also. I'm just showing different approach to do this. So, okay. The last one is, okay, last one is for 20 yards. So let me write 20 yards, and you need to write this into meters, right? To change this into meters, we don't, of course, if you can do that, but I wanted to write first change uh, yards to, because our main thing is 1 inch is 2.54 centimeter. Okay, so first we'll change yards to feet because 1 yard is, so we know 1 yard is 3 feet. Okay, and 1 foot is 12 inches. So these are the ones we can use. So if it is 20 yards, so we'll begin with 20 yards. Okay. Now multiply by a rate, and the rate is 1 yard because yard is up here. I'm using 1 yard down is 3 feet. Okay. And then again we can write another rate to show 1 feet. All right, at FT is 12 inches. And then I'm going to convert this into 1 inch. 1 inch is 2.54 centimeters. So this part, so this piece, this is same as writing 1 inch divided by 2.54 centimeters. This is one way to write, or you can write 2.54 centimeter up and divide by 1 inch. So I'm going to use this piece here. The reason is there is an inch right here, and then we can cross out the yard and a yard will go, feet and feet will go, inches and inches will go. So what I left is just 23 times 12 times 5, 2.54. So, and all this answer will be in centimeters. And you can see the answer that you get is uh, 18, 18.288. Uh, I think I missed because the question is asking us to change it to so you have to write also one more. You have to. Hmm? I missed the question was asked to convert to meters. So I think I forgot that about meters. I changed this to centimeters, but then you also have to change from centimeters. So centimeter is up here. So I'm going to write centimeter here and meter up. So this is meter. So when M stands for meter, MI stands for mile. Remember, there is a difference between these two. This is mile. So I want to write meter. So what I have to do is 1 meter is 100 centimeter. And you can see what is 1 meter is like a one. If this is a meter, this is 1 meter starts with zero, and this is 1 meter. But in between there are 100 centimeters like this. Right? So there are 100 centimeter like this. So this is like 10, 20, 30, and so on. There are hundreds. So that's why that 100 centimeter. So now we will have to multiply this by 2.54 here, this one, and then multiply by, of course, this centimeter also will cross out. So, and you're getting the 100 will remain in the denominator. So this is 100. And all this answer is in meters. So on the calculator, when you put this, all this, you multiply 2 times 3, 6, 6, 12. Okay, 6 times 96, and then you multiply this, you end up getting 18.288 meters. You're done. So in example number 5, you have to convert the following to the units given below. So from 45 feet square, we need to convert to yard square. So this is 45 feet square. Now we don't know what is this 45. Is it 9 times 5 is 45, or is it 15 times 3 like this? 15 and 3 also gives you 4. We don't know. That's the dimension. This we don't know. It's, but the main thing is there is that the feet. So the length is the feet, and then again you have the width is the feet, and that's why feet times feet is you get area is in whatever that is 45 feet square. And the same if you do like this also, this is 3 feet, maybe this is 15 feet. So this area will be 45 feet square. Now we need to convert this into, that means each of these feet, so this the length and the width, let's see. So what I'm going to do is I'm going to start with 45 feet, and it is square, right? So we first will try to change this into each of these feet is how many yards. So we want to write, there's a feet in the numerator, write the feet in the denominator, and you know to change to yards, you know 1 yard is 3 feet. And then you have to do one more rate, you have to multiply. Again, you do 1 yard is 3 feet. So this is what is needed. So it becomes a little confusing. The reason to do this, we can cross out, there is this feet and feet. It means like this, feet times feet. Basically, it means it is feet square. So that's why these two at the bottom, the feet and feet, got cross out with this. So what I left is 45 times 3. So this 3, when you multiply, becomes directly you can write 9, and everything that you get is, this is like yard square. Of course, we don't need calculator. You know it is 9 goes 5 yard square, and that's done. So this is called dimensional analysis. This problem is easy. What instead of 45, it was 53 feet square. Then we need a calculator. So let's do another one, that 2 meter cube. So 2 meter cube. Now this is a meter cube. What is meter cube is? Meter times meter times meter. It means you have a length, you have a width, and there is a height. See? So something like this maybe. Okay, so this will be the volume. Now, so this will be in meters. This is in meters, and this is in meter, the height. So there are three parts: meter, meter, meter. And that's why you see this 2 meter cube. We don't know what is the dimension, or how much is this length or width, or we don't know all these pieces. But they want to change to centimeter square. So all you do is 1 meter is 100 centimeter. So starting with 2 meter, I'll start with 2 meter cube. 2 meter cube is 2 meter, meter, meter. And then every 1 meter, you write 1 meter down is 100 centimeter. Again, one more meter, you write down 100 centimeter. Again, you multiply 1 meter is 100 centimeter. So we can cross out this meter to this one to this one, this one to this one. So what I left is this 2 times 100 times 100. You can see it is 6 zeros here. So 1, 2, 3, another 3, and 2 million. So this is 2 million, and there is centimeter, centimeter, centimeter. So that becomes total centimeter cube, three of them, or cubic centimeter. Another way to say is cubic centimeter. So with more and more examples, when you practice, you understand. Let's do another one. So this is the example problem number. I think it is. Let me check. Problem number 6.1. A bicycle is traveling 15 miles per hour. So they gave you 1 hour is 15 miles. So this is one way of writing. And you could also write 1 hour up here and divide by 15 miles. This is another rate. So both are correct, but depends on what question is asked. So here they're asking how many feet will it cover in 20 seconds. So you're given started with 20. So I'm going to start with 20 seconds. Okay. And then now see I started with the time. The time is in the numerator. See. So divide by 1. So when you want to write one of these pieces, you want to make sure time is down. And you can see here, this is a better option. Like 1 hour is, so 1 hour is 15 miles. Now we also have to change. You can't. You have to have this hour. Let's say mile. This mile is in the numerator, so you need to write 1 mile is how many feet. Okay. Now the unit rate or the dimension analysis says 1 mile is 5,280 feet. See, this is how you're supposed to know. Of course, you have the formulas, and then change this to this part is done. Then you also have to change the hour. So can you see this hour? So because the hour is down, the denominator 1 hour, we know 1 hour is 60 minutes, right? So that means uh, you can write two different ways. 1 hour is 60 minutes. Okay, minutes is one way to write, or you can write 60 minutes and 1 hour. This both are same. So it depends on what you are asked. And because there is a 1 hour here, I'm going to put 1 hour up here. So you want to. So our goal is to cross out this 1 hour and this 1 hour here. So 1 hour is right on. This is the piece we will copy and paste here. So this will be 60 minutes. And then again, we can write down. You don't want minutes to change 1 minute. Eventually, you want answer to be in feet, right? You don't want anything in time. So this 1 minute has 60 seconds. Okay. So we want to get final answer to be in feet. So what's going on is this second that you have, this crosses out. I'm using different colors to have this mile and this mile crosses out. Then yellow, this hour and this hour crosses out. And eventually you get This minute and this minute crosses out. So what I left is 20 times 15 times 5, 280, and then divide by 60 times. So these two 60s are left, 60 and 60. So 60 times 60. So when you put this in the calculator, the numerator you can all multiply to straight away, all these four numbers. But when you do the division, be careful. You have to use the open parenthesis, and then you do 60, and then multiply another 60, and then close with the parenthesis, close parenthesis, and then enter. So this is what you do on the calculator, and I think you get the answer to be 440. So you get 440 feet. This is example number 6. A 1,000 foot spool of bare 12 gauge copper wires. Okay. So it weighs, so this is important. 1,000 foot, 1,000 foot weighs, okay, this is equal to like 19.8. I just want to show you, this is one way to write, or you can say 1,000 feet divided by 19.8 pounds pounds is is one of the rate, or you can say 19.8 pounds divided by 1,000 foot. Okay, so these are all the information they give from here. Now the question is, how much will 18 inch? So that means we have to convert from, our goal is to convert inches to ounces. So this is the our goal. So you, whatever this in inches, now this 12, whatever the 12 that is, this is not required. This is just given. It's how thickness is the wire. And spool is like a wheel that where the wire is wound around it. So how do we do this is you start with, so it can be done in a different ways, but I would start with 18 inches. So to start with 18 inches. So this is 18 inches. Now you have to multiply by the uh, conversion factor, I call it, or the rate. The rate now, because it is inches, and this is the length, right? This is the length. So which would be the better options here? Would be so is this better or is this better? And because the inches is there in the numerator, you want to find out which one the length is down, and you can see this feet is down here. So I'm going to use 1,000 feet. This is the distance, right? So 1 foot. I'm going to use this box, 19.8 pounds. Okay, so that's the multiplying the conversion factor or the rate. This is the rate I'm using because of the length. And after that, you need to convert this into each of this. We have to convert to, let's see, pounds. So because pound is up here, I'll write pound down. So 1 pound we know is 16 ounces, right? 16 ounces. So that takes care of converting from this piece, the pounds, and then now not over. So now look at this. This is feet. So you have to have feet up here, and you have to convert this into uh, inches, because see we started with inches, so that has to go away. So 1 foot. So 1 foot is 12 inches. So this is how you multiply the rates. This is the first rate I multiply, and this is the second rate. And the reason I already explained why is because this was distance. I'm saying one more time. So this is distance or length. So you're using this because you have to look up where the length is down, because this length is over 1. See, so here it is up. So you're looking up when it is down. That's why I use this piece first. Then each of the numerator and denominator uh, has to be converted pounds. So I multiply this one so that we can cross out the pound, and pound will cross out. So the inches and inches will cross out. The feet and feet will cross. What I left is 18, and you divide by this 12. All this answer is in ounces. See, this will be answer. And you end up getting 0.4752 ounces. So this is how, of course, you can do different ways, but I would always start with whatever they gave you. This is the starting point, 18 inches. You multiply the one of the factor because you want to write the inches. Okay, so I hope as we do more practice problem, we'll understand more better. So let's go for another. So from now, how do how do we apply this in real life? Okay, so you see in geometry, this is needed again in construction, especially. Let's see here. What is the meaning of a perimeter? Perimeter means length around. Like let's see, this one is a rectangle. So rectangle means you're adding the two lengths. So this is the length. This also is the length, and this is the width in the red color. So the width. So the two red are the width. So it is W all around. If you add, and you can see this is the length L. It is L plus L, and you can see 2L and plus 2 width. So that's why we use perimeter is P is this formula per, and the area of the rectangle is length times the width. So this is you know already. Regarding the circle, the diameter is the longest, the long chord, but this long chord it has two radii. So from the center to the end point, this is the radius. So this is one radius, this is another radius. In other words, you have diameter is, so here the diameter is 2 times the radius. And what is circumference is basically how much is all around. Now this circumference is C, here it is C equals 2 pi r. So it is 2 pi r, or also you can write this as pi times 2r, but 2r is twice the radius is the diameter. So you can use this formula also directly. And for the triangle is the base, this is the base, this is the triangle, so this is the base, the distance. And how high is this triangle is the height h. And that's why we have this half b times the height. And perimeter is all the lengths adding around. So we'll take one example directly. Let's see, hey, add all around this is the perimeter. So depend on the situation, what question is asked, we'll do. So this is example number 7. A circular shaped sandbox is to be constructed from bricks that are, each of this brick is given to use, and also they give us in inches. And the diameter of the sandbox was measured to be 12. So it is circular, which means, let's put it like this. So this is circular, and this has to be covered with bricks of almost like a half foot. So we want to know how many of this will fit in. So this is the question: is how many of these bricks has to be fill in the entire circular means the circumference. So I'll just do. So this is what the first step is. We have to figure out what is the circumference, and to find the circumference, they give you the diameter. So the diameter, this part is given to you as 12 foot. So halfway down will be, so the radius is two times the radius is the diameter, right? So because they gave us the diameter as 12, so I just want to make sure we first let's find out what is the circumference all around. What is this length? And because this is given to you is 12 feet, okay, 12 feet. First, we'll convert this into how many inches. So first, 12 feet. Let's find out the circumference all around. How much is the distance all around will be circumference is 2 pi r, right? Which is actually also, this time I'll write directly pi times the diameter because they gave us the diameter. So the diameter is given. So it is pi is 3.14 and you multiply by 12 feet and you end up getting that answer to be 37.699. So this is in feet. Okay. So the circumference is given in feet, which we have to convert this 37 feet circumference. Let's change it to inches. So circumference, which is 37,699 feet, to convert to inches because the brick is given in inches. So I'll write this as 1 foot is 12 inches. So we can multiply these two pieces and you get circumference now, I mean the distance all around is, we get 452.4 inches. Now, so once you get this, the distance all around this, and we see we want to know how many of these bricks, the red color. So we don't know how many of those pieces all around is this 452. So the total has to be 452.4 inch, and then we want to know each of this brick. Okay, so that means number of brick. Each brick is, so this is like number of bricks. You want to know how many bricks, right? Number of bricks times each brick is 7.625. So the number of bricks we can replace it by maybe n. That's n times this becomes n. So it's like how many of 7.65? So all you do is divide by 7.625 here, 7.625 here, and this crosses R, and the n is, by dividing those answers, you get 59.33, which will round it to 60 bricks. So all these are the pieces you need, all around 60 bricks to put around the whole circle. So the question was, how many bricks should you purchase if we assume the brick when laid out is approximately a circular shape like this. So again, I just want to wind up. First, find the circumference you get in feet. Change the circumference into inches, and then use this idea of uh, is the length of one brick is this. So how many of those add to it? It's like saying 7625 plus 7625 plus 7625. How many of this together make up like this? Go on doing, and you end up getting 452. You want to know how many of those, and that's why I said we don't know how many of these pieces. So I put that multiply by n here. So 7, and you get the answer. So this one is next is about the volume. So we have seen the 2D. This is 3D. Three-dimensional is volume of a prism. Like this is the prism, a box. Again, the box is length, width, and the height. So the volume is straight away this formula, but the surface area is little. It's like 2 to 3 pieces are there. The front and the back. So this is the front. You can see back. That is the back. There is also sideways like this. So those will be another. So this will be like a length and the height. So and then there are the up and down. So this will be the up down. So each of this, and the front and the back will be like this. Front and the back will be like this. So that will be, front is the height and the length. See, height and the length. So this will, and the bottom and the top. This bottom and the bottom is VWL, and this is WL. So each time you multiply, this will be 2LW. So when you multiply this, it will be LH 2 times HL or L. That's this piece. And this is like the front and the back, which is the length into height and the length. So this one is this, and this is width and the length. This is height and the length. Oh, they took as width and the length. Okay. Anyways, I'm always used to writing this as the length. So anyway, don't want to get confused. Let's go directly to what I'm talking about is they gave this as the width and this is the length. So that way I made a mistake. So anyway, the main thing is I wanted to show how this formula. Then there is also a volume of a cylinder that you see here. There is a backside, there is a radius here, which is R. So there are two areas, up and down. So if we are talking about surface area, this is because there are two pieces up and down. Each area of a circle is pi r square. So this is pi r square. There is another pi r square. Together is 2 pi r square. And when you cut open this, if you try to cut open this can, you end up getting something like this, where the height is this h. So this is the height, and all around the circle at the bottom, this is this piece all around. So this is that, which is, if I take this as the radius, the circumference, it is 2 pi r. Okay, so this is 2 pi r. And when you multiply the length and the width, this is the length and the width. So you end up getting the area of this uh, lateral surface, lateral area. This is also called lateral area sideways. Okay, so you have two bases, which is 2 pi r square, this and this, and there is this piece, which is a rectangle, and that's how you get. When you multiply this, this is 2 pi r, and you multiply h. So you have this answer right here. Let's see how we can use this. Okay, in this example number 8, a local preschool is installing a new sandbox in their outdoor play. The playground designer has specified the dimensions. The length is given, width is given. Can you see this? So these are already given in feet. Uh, so basically, this is like, let's say this is like 12 length. This is like 12 feet. Okay, and 8 feet is the width. So this will be like a 8 feet. Okay. This is 8 feet, but the height it is given in inches. So we have to first convert this into 12 inches. So this 12 inches has to be converted to feet. And you do know 1 feet is 12 inches. See? So you're going to multiply this. And when you do this inch and this crosses out, you get 15 divided by 12. And if you work this, this will be your answer. And that answer turns out to be 1.25 feet. That means I'll have 1 foot, 1.25 like this. Okay. So I'll have to do like this to draw and then draw like this. Okay. And this 8 foot will be like this. Hmm? So I'll have to do, of course, this is 1 point, each one is 1.25, and this is the height. Uh, and you can see the back side. Of course, I'm just, the figure is not important. I just wanted to show here. Okay, that part we can see. Because the height is very small, tiny. So this is the height 1.25. So we can find the volume of this playground by length. This is the length. This is the width. And now we got the height, which is the height h. So first we'll find the volume of the playground. So length with height. So if you multiply all this, it's 12 feet. 12 feet times 8 feet times 1.25 feet. So that will be feet cube, right? So that will be feet, cubic feet. So this is like cubic feet. And so or feet cube also. And when you multiply 12 times 8, and this, I think you end up getting 120 feet cube. So 120. So the volume is 120 feet cube. But then we are told that every cubic yard is $30. So we need to know the whole volume. So the volume is, we have to convert the volume into yards. And so this yard, so even though we got 120 this, so I'm going to write 120 feet cube. This has to be converted to yard. And this means the feet cubes, I have to write three pieces like this because we can write one yard is 3 feet. 1 yard is 3 feet. 1 yard is 3 feet like this. And when you work this out, you can see this what crosses out is the feet cube will cross out with this three. I mean the feet, whatever the feet. The number that you are left is will be 120 times divide by 3, 3, and 3, and this whole thing is yard cube because there are 3 yard. And when you multiply all this, you get 4.44 yard cube. And now the ending part is each yard cube is given to you $30. So all you do is 4.44 yard cube because yard cube is the up. So now I'm gonna write 1 yard cube is again conversion factor. The rate is given, every 1 yard cube is given to you is $30. So this is $30. So all you do is multiply this two and you get the feet. This and this crosses out, and what I left with is just multiplying this 4.44 and 30 on the calculator, and you should get the cost $150. Okay, so I hope that makes sense to understand this what I'm talking about. This is another nice example. I think example number 9. A company. So this is example number 9. You can see a company makes a regular and a jumbo. So this one is the regular marshmallows. This is the regular one, and this is the jumbo one. Now you can see at the back there's a grid just to know how much is the diameter. Like in this case, if you see the first regular one, the diameter is from this end, so to all the way to here. So it's like you have 1, 2, 3.5. See, so this is the diameter, which is 3.5, and for this one, it is from here to here is like you can see 1, 2, 3, 4, and 5, and 5.5. So this is 5.5. Now, if you want to take the half of the diameter, so you have to know the diameter half of this. So this will be 3.5 divided by 2. So you end up getting 1.75. You can check with the calculator. So this is 1.75. And the other one, if this is 5.5, so you want to know what is the radius here. So this radius will be half of 5.5 will be 2.75. So this will be 2.575. So all you do is we want to know what is the volume of this and what is the volume of this, because our goal is to find how many calories does this have. So calories, we want to know the jumbo marshmallow has got how many calories, but this one they give you is 25 calories. So we'll try to get that first. So let's do one thing at a time. Let's see what is the volume of the smaller one. So we want to know what is this volume. So this is in the cylindrical shape. So the volume of a cylinder, remember the formula is pi r square into height. So you can use pi, and the radius is here 1.75. So 1.75 square. And the height is, so how high is this? Now, if you see it looks like how high is, it looks like it is 3, but it is not 3, it is 3.5. So why it is 3.5 is because, see, the table which shows here at the bottom is not shown properly. It means if you go a little downish, this piece goes up here like this. So it is like 3.5 here. How 3.5? 1, 2, 3, and half. So the radius here is, I mean the height. The height is, this height is, if you bring your eye level down, so if you bring eye level down, you will see it's going to be here. So this will be 3.5. In the calculator, if you work out, you get 33.7. They didn't give us what is this unit, whether it is half inch or centimeter. We don't know. So I'll just write unit cube because this is a volume. Volume is always cubic. Now this is the V. Now let's say the big V. That means the jumbo. You need to figure out what's the volume of this one. And again, I'm using pi r square times the. Now this height will be different. This will be h1. This may be h2. Radius 2 is the second, the big one, or you can say the biggie or jumbo, whatever that is. Let's put it 2 only. So this is going to be pi. Okay, multiply. And now the radius is 2.75. So that's 2.75 the whole square times how high is this? And you can see this is almost exactly like a, even though it looks like a half, but see, if you see this jumbo marshmallow, if you keep your eye down, so this goes to here. We'll see this will be looks like this. So that part is 1, 2, 3, 4, and 5. So multiply by 5. You do this, you get 1.118 plus unit cube. Okay, now we go directly to the calories. We are using the unit rate. Let me, okay. So begin with the smaller one. The smaller one that you see here has 25 calories. So we want to know how many calories this one, right? So let's start with we want how many calories a jumbo. So now this one, the big one has volume. We got the big one is 180. So I'll write 108 in the big one, 118.8 a unit cube. Now you have to multiply something up, something down. So what is that something up, something down means? This basically means 20, the smaller one is 25 calories is this one, 33 has a volume of this unit cube. Okay. That is, so what we can write is, if I divide 33.7 unit cube divide by 25 calories will be one of the rate. This is the rate. But because there's a unit cube up here, this will not help. So what you can do is the other one. That means you write 25 calories up and divide by 33.7 unit cube down. So this will be the one that we are going to use here. So you're multiplying 33.7 unit cube, and the top one is 25 calories. So this is the smaller one. So this piece, I'm talking about this smaller piece, we are using this rate, saying that the volume is down and the number of calories is up. So we can cross this our unit cube, and what are you left with is 118.8 times 25, and then divide by 33.7. This whole thing will be in calories. So this is calories. And so with the help of a calculator, you will get the answer as, I think it is 88. 88.1 calories. Okay, I hope this makes sense to you. And one more thing I would know, to be taken note is just if you see the lengthwise, this small and the big marshmallow, the volume doesn't increase exactly the same ratio. Let's see remember the diameter here was, so the diameter here we have taken 3.5 and the diameter here was 5. And if you take a simple ratio of how big is this diameter, you can do 5.5 divided by 3.5, and this is almost like 1.1 and a half kind of increases. But the problem is the volume, if you see this is 33.7 and this one, it doesn't go increase the same amount. So if you see it is going to be increased by, because there is a length, width, and the height. If you do 1.5 raised to 3, that 1.5 cube times 1 the smaller one almost becomes equal to the bigger one like this. Uh, I mean the smaller 1.5 cubic multiplied by this this 3.33.7, so that will be equal to almost like 100. So it's like it's the so it gets scaled by scale factor 1.5. So if the length grows by scale factor of 1.5, the volume grows by cube of whatever that this 1.5. Anyway, just wanted to show uh, understanding of this.